All right, we're live, I think. Okay, it's Saturday. I'm with my daughter. I decided that I want to try to finish off this feature because I'm really excited about it, basically. So let's try. Let's attempt to get this done. So yesterday I finished step 1 of this to-do list, which was traverse the AST to figure out which functions need closures from which functions. And let me show you the fruits of that labor here. I think that script was called closure info, and you would give to it a closure, well, a program in the play programming language. Oh, you want to give to it a AST file. Oh, but at the moment we have an error that this misspelled variable name is undefined. And I'll show you that. This variable name has been misspelled, and the checker is the closure info. Well, the closure info gatherer has a sort of a variable usage checker in it as well, and it can pick up when you have when you're referencing undefined variables. Okay, so I'm gonna change this and compile closure example for.play again to generate the AST file, and now I do it, and it will tell you the closure information that we need, which includes the closure providers and the closure dependencies. Excuse me, let me get my stylus. Alright, I'm back with my stylus. So, okay, I drew this out last time, but let's see. We're using the ES map, and that's what this is. So this whole big old thing, actually from here, all of this is one big ES map. ES map is like a JavaScript object, except its keys can be objects. The keys don't have to be strings, so this here thing is a key value entry. Okay, the key and value is separated, but there's a little arrow notation here, and this guy is the key and this guy is the value. So that is saying this node, this AST node, which represents a function definition, that's the key, and the value is the set of strings which contains counter and counter2. What I'm using this to mean is that this function, which is the main function is gonna need to provide, thus the name closure providers. It's gonna need to provide these two variables within a closure. So the main function, it defines these two variables. That is saying it needs to provide them within a closure instead of putting them on the stack as is normally done. And it does it for all the things. For example, for the it also says that the initialize UI function, which is here, it needs to provide the label variable within a closure, and label variable is this. Why does it need to provide these things as a closure? Well, the next map called closure dependencies that will tell you, and it's because there are two arrow functions. One of them is this guy, and another one of them is this guy. Okay, this guy here, this arrow function here, corresponds to this function, and this function needs from the main function the counter variable, and you can see that being referenced here, here, and here. These references to the counter variable are referring to this counter variable that was defined in the main function, and this is also saying that it needs the label variable which was defined within initialize UI, which is this middle function here, and the use of the label variable is here. So this label refers to the label that was defined on this line here, and then we have a second function which is referring to the counter 2, which is defined again on the main function. So that's the information we have based on the work we did yesterday. This time I'm gonna use this information to update the generator, we'll have the generator use this information to make decisions about how to generate the code. And we have the steps here. We have the steps in my notes, which is nice because that means we can follow step by step. So we're gonna start with step number 2, which is for the functions whose variables are dependent on by inner functions, which those are the ones where the closure providers, where it has a some set for the function as the closure provider is defined. For those functions, we're gonna need to make these two changes. One is we need to allocate an aptly named closure. I think I'm gonna just call it $, maybe call this aptly named closure, maybe call it $main closure. So that maybe like the function name here, the function name, and then closure. And then we're gonna add the closure created to the push frame call. Okay, let's go ahead and do that. The first thing we need to do is actually make use of the code we wrote yesterday. And since at the moment that code is inside this, it's called closure info.js. Yeah, inside this closure info.js file, I'm gonna grab that function out of this file and the other related functions out of this file and move it into a module that is in the source folder. I'm gonna call that closure info probably, or maybe just closure. Just call it closure. Oh, except closure already exists. I already had a find closures function. I had already attempted this once, but I don't even remember it. Well, I'm gonna disregard that one and replace it with this one because I don't think I got to where I needed to go the last time I attempted this. So I'm just gonna disregard that one. Okay, and then I'm gonna say export module or exports dot gather closure info is this function gather closure info, and plus it has these other functions. I'm gonna try using this one in the existing script here. We don't actually need the traverser. We do need the traverse function from the traverser library, which it's gonna be this relative path. So now we don't need this line here. I'll say gather closure info. So I call this closure. That is crazy. All right, let me try to run this function script again, and it still works, except this time using the gather closure info from within a library. Now, that library can be required from my generator as well. Oops. Okay, so now that I have this guy, I can actually run this guy on the AST. Do I need to give... Okay, how do I call this? Oh, I need to call it like this. Okay. Possibly I can improve this by making the inputs less, but for now that's fine. Okay, I'll call this closure. Well, actually it doesn't really return the return value of this thing isn't even what I'm interested in. It doesn't even return anything, so there's no need to save its output. The output that I'm concerned with is the closure providers and the closure dependencies. Okay. So at this point, I'm going to need... So the code generator is also a function that's recursive in nature, and because of that, I kind of need to pass in these two pieces of information into it. And if we pass something into a recursive function, it kind of has to pass the information to all of the child calls. In order that all the nested recursions have access to that context as well. Unless you do some kind of weird trick, which I kind of don't want to do. I don't want to do anything weird. So I think what I'm going to do is introduce a closure info object, which just contains the providers and the dependencies. Okay. And then I'm gonna pass this closure info into the code generator like this. Actually, before doing that, I'm just gonna print this out to make sure that that much of it worked. But this one is the code generator. So let me try. So first parse a program. Say, I haven't tested the gather closure info function all that thoroughly, I must say. So there might be bugs in it that I will need to fix later. I just wanna put that out there. Okay, so I'm gonna parse, although I have already parsed that file. I'm just gonna generate the closure example number 4 AST and that seems to have worked. We print out the closure info and it's there, so that's fine. Now we just need to pass it in, and then this is gonna receive it, and then it needs to pass to all the sub child calls that would potentially need this closure info. I think the expression thing definitely needs it. The code block thing definitely needs it, because both of those are complex syntax elements that could potentially contain function definitions or function expressions within them. So all of these will need to use the closure info at some point. Oh, this is call expression. Call expression could need it too, because a call expression is like a function call like this, and inside the function call you could have an anonymous function, which is called function expression, embedded in there. So that guy does need it as well. Statement is this function itself, so that is a recursive call to itself, so it needs it. This is generate code for if alternate. The alternate clause of an if statement has a code block in it, so it will need it, and that will need it. This will need it. This will need it. Yes. 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 Generate function. Yes, a function definitely will need it, because a function inside of a function is another code block which can have any code in it, including nested functions. Whoa, what is this pause after thingamajiggy? Dang it. Okay. So for this pause after thingamajiggy, well, that makes it hard for me, because but that's okay. That means all the ones that are calling in to generate call expression. Oh, actually there's only there are only two calls to generate call expression. There's a pause after parameter, which is optional, and if I am going to add another parameter to it, then I need to add it to the second place. So I'll add it here, yes, but if I do that, then to the definition I would want to add it here. No, not that, closure info. I would need to add it here. Okay, that was a delicate case. Okay, let me continue looking through this code here now. Okay, so I added closure info as second parameter to most of these function calls, all of them actually. I can't even remember one where I did not add it. Now I'm gonna add it to this guy. Okay, now I'm gonna add it to this guy. Okay, and now I'm going to add it to this guy. I did this guy already. This guy, this guy, this guy. And then I want to add it to this guy and this guy. Oh, and that's the end. I went through all of the code. Wow, I wonder if this worked. The only way to find out is to run it again. It generates a file. It's called closure. Let me see. That file is called closure example number 4. And I mean, it looks okay to me. So I think I've introduced the new parameter successfully. Oh, by the way, if you're using a statically typed programming language such as TypeScript or C#, then that process you would have had some help from the type checker. Because if you introduce a new parameter and then you try to call that function without that newly added parameter, then it will error in the various places. What I did was basically a very, very careful insertion and sort of like a line by line sort of hunt of all the places that I would need to change. And to introduce the parameter correctly. And I'm still not 100% sure that I did everything correctly because I could have made a mistake. But if I made a mistake, then I will just debug it when the problem comes. But right now I'm pretty confident that I did at least most of the things correctly, and now I'm going to try to make use of the closure info in the places where we need to do that. I'm going to start with step number 2, which is for all the functions who are closure providers, basically. So if I'm generating code for a function, I think there's a function dedicated to generating code for a function. Now I know that this assumes the node is either a function definition or a function expression, I believe. I feel pretty confident about that. Yeah, because otherwise it would have no function name. Okay, I'll just make sure. Yeah, if it's a function expression, it will also call this generate function. Okay, so at this point, I'm going to look up the closure info. Closure provider, closure info dot closure dot provider dot get node, because the key is the AST node. I can use this provider. Did I call it provider or providers? I called it providers. Okay. Providers. Okay, then I get this closure provider. Now I can say, well, if it had a closure provider, then I'm gonna need to allocate a closure on the heap. Yeah. Where should I do that? I have line 1 here, so probably I did it in, right below this line. So I'm gonna say, yeah, closure line. Maybe I'll make I'm just gonna say if has yeah, if I am a closure provider, then I wanna add a line. Should I do a blank line? If there, I kind of don't want to have like a empty line. How should I do this? This is an array of lines which at the end will get joined, separated by a new line. Maybe I do it like this. maybe closure. That's line 1. I'm gonna call this guy line 2. Line 2. Okay, that's line 2. But optionally, line 2 can have a closure line, maybe. So maybe like plus. If there's a closure provider, then blah blah blah, else empty string. Let's do it like this. So the blah 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 is the line that says the closure name. Oh wait, the function may not have a name. I forgot about that one. I'm gonna cover that case later. But the name of the closure would have been the name of the function, which is fun name, dollar, the name of the function, and then closure. And this is gonna be the name of the variable, equals heap allocate, and then an empty dictionary. Okay. So if you have a, and I don't know, because this needs to be uptick. Okay, so that's line 2. Line 2 is this whole thing. If you have a closure provider, it's gonna do this to you, basically. Let me see if that works now. I'll regenerate the source code. No, it did not work. Syntax error. Where is the syntax error? Oh, I need a parenthesis to close this parenthesis. Obviously. Okay. So now yeah, it's got this main closure thingamajiggy here, which can be used in the various variables, including the nested functions. I kind of want to put a new line there. I want to put a new line here, and I want to indent the thing. Like that. Just for formatting's sake. That code looks a little weird, but oh, I guess I didn't have to indent it. Why? I'm not 100% sure why. But okay. I'll take it. I think it's because my indent function probably will indent multiple lines. That's my guess. Yeah, so this works. Great. So that's the main closure. Later on, I'm gonna have to handle the case when, like, this is actually a anonymous function. I can't use the name of the function if it doesn't have a name. But I'm not gonna do that yet. I mean, I could use a number here, like have a counter and use a number here, but I'll worry about that later. I just want to get it to work right now, quickly. because I'm impatient. Okay, so, and also this initialize UI closure also has one because it also needs to provide some variables to an inner function. But this one doesn't because this is the innermost function already, and it's not needing to provide variables to an even inner function. Okay, so that all makes sense, and I think I have done that step 2a. That step 2b is add the closure created above to the push frame call. So I had to do something to the push frame call. So I decided that my push frame was gonna take in an array of closures, and it'll just stick them in here, into the frame object. In cases where the thing doesn't have closures, then this will just have nothing. But in the case where it does, then it needs to be passed in to this push frame function. So this line of generated code, we want to put in that name basically, main underscore closure, like that. In the case that this line generated a closure. Okay, but not in the only for that case. Okay, so I'm gonna move this line out and maybe call this line push frame line. And I could tweak this line depending on the situation. Let me think about this a little bit. I'm starting to think maybe I should, like, this line, this code is getting a little crazy. So I'm gonna maybe call these guys initialization lines, and I'll append to the line, or a push to this initialization lines array as I go, and then I will spread them onto this outer array. But then instead of doing this crazy ternary here, which I usually don't like, I would rewrite this as an if statement, closure provider, and then which will push a line onto here. Oops. There. And then there are only two cases: the case where there is a closure provider, or the case where there isn't. So if there isn't a closure provider, I want the push frame line to remain the same, just like that. But if there is a closure provider, I want the push frame line to look like this instead. It's gonna reuse this name, but since I'm gonna use that twice, I'm gonna call this the closure name, closure var name. I just call it closure var to be slightly shorter. So this is closure var, and then the closure var is also going here. In that case, it needs to be wrapped inside of an array because it actually expects an array for the closures. All right, let me try this. And looks beautiful. Now this closure. Wait, oh, I need to indent these lines. I'm having to type indent. I feel like a little too much. There might be a slicker way to write this so that I don't have to type indent so many times. But I want to get it to work first. Okay, that looks wonderful. That's what I wanted. The closure that was allocated should get passed in to the push frame call, and the same thing happened here. And I think we have done number 2 at this point. I don't know why this is looking so funky. Oh, because of that. Markdown thinks that has some special meaning. Okay. Is there a way to escape it? Okay, there we go. I've done number 2 now. Wonderful. Now for each inner function that depends on an outer scope, we need to add the list of closures we need to the push frame call. So that is that would be in the example. Let me go to the program example here. This one. So it's this one. In this inner function, we need to add the closure for the main and the closure for the initialized UI to its push frame call. So that corresponds to here. So this push frame, it needs to have both this and this closure in there. Okay, how can it tell? Well, because we have this closure dependencies entry, and that is cool. That is super cool. So let's grab that entry. It's like, do I have any closure dependencies, sir? Okay, so one case we'll have to consider is when a function both has is a closure provider and it has closure dependencies as well. We'll have to deal with that case maybe sooner than later, because both of them will need to put stuff in this array here. Let me think. Maybe what I do is keep track, like this is gather elements into this array, and then at the end generate this line based on the contents of this array. So I'm gonna call this closures array. Closures, yeah, array. I can't think of a better name. So instead of having this line here, I'm gonna move it out, put it in here. But we'll tweak this. Okay. And then the closures array will get an entry into it if we have a closure provider. You'll put the closure var in there. But also, if I happen to have a closure dependencies, then if closure dependencies which I think closure dependencies is a dictionary, I believe. So I'm gonna loop through it. Fun name in closure dependencies. That was probably a bad choice because again, we are not handling anonymous functions. Dang it. We'll have to change that. Okay, but anyway, the closure var is again that, and we have the fun name here, so that same line works just as well. And then I'll push that into the closures array. Okay, so now we can have a closures array that can have multiple things in it, and then there should go in here. I guess if it's happens to be an empty array, we actually do want a undefined or just not provide this params. So maybe I do an if statement. If closures array length is 0, then we do a version of that without that argument. But if it had stuff in it, then this should be closures array dot join. Like that. And put the brackets around it to make it like an array. I think that works. Let's see. 163 have a syntax error. What's going on? What's the error? Missing closing bracket. Oh. Alright, let's see if that worked. Yeah, that worked. So this inner function is referencing both of the closures that were allocated here and here. This one has itself, this one has itself, and which is also what I wanted. Beautiful. And this one only depends on main and not initialize UI. This is exactly what I wanted. Perfect. So I have done number 3 as well. Now number 4. Number 4, we need to replace every one of the set variable calls or get variable calls if it is referring to a closure. A variable that's in a closure, whether you're providing that closure or you're using that closure. They need to switch to using set heap variable or get heap variable. So, all right. That is actually, where is set variable? Set variable, oh, there's several places that use set variable. 1, 2, 3. 2, 3. And it includes for loops too. All right, let me think about this one. Okay. Well, this could get, there's 3 places that need this, so we may want to extract this logic into a common place. But we'll just make one of them work at a time. So there's a return statement. Return statement. We don't want to do it for return statements, so that one we don't actually have to change. Return statement set this special variable to remember the return value, just so that the debugger can display the return value before it actually returns. So that's never going to be in a closure because it's not a named variable. So then the only two cases where we're doing set variable is the for loop for the loop counter. The loop counter, could that potentially be in a closure? Yes, it could. Although we don't have a test case that does that at the moment. But we'll make sure we make a test case for that. Most likely it's not gonna work out the door. Okay. Okay, so I'm just gonna concentrate on this one. We're doing it to a var assignment. So we're gonna say if we need to look at the closure provider. Closure info dot providers dot get statement. This time the node is called statement. Maybe I should have just called it node. Not sure. To be consistent. Okay, so basically if there is a closure provider, or if I am a closure provider, and the var name is set var statement is one of the two. So in the case where there is a closure provider and the closure provider has, because I think closure provider gives you a set, if I remember correctly. I can run that closure info program again, right? So a closure provider is a map. It gives you a set, and a set has a has method, which can tell you whether it has that thing, which the things it would have are strings, which var name also. So if we are providing this variable, then we want to do the set heap variable thing. Otherwise, we want to do the normal set variable thing. And when you are doing set heap variable, you need to pass in the closure from which that variable is stored. So again, we need to calculate the closure var name again based on the, oh shoot, this is not gonna work because the statement is a var assignment, not a function. So I don't know what function I'm inside of at the moment. That's a problem. I want to illustrate what the problem is, in case anyone is watching. So let's say you have let's say okay. So here we have a function node. Have a function node representing the main function, and it has first it has another function node representing the initialize UI function. I'll abbreviate it, and then it has a var assignment statement, which has counter and 1. This is a number literal, and this is counter is an identifier, and so forth. So in the code, and there's a couple of other statements. There's another var sign. This is 1 also. This is counter 2. And then there's yet another statement, which is a call expression. Okay. And yeah, it's got stuff in there as well. So we're basically iterating this tree. We're first visiting this guy, and then we're visiting this guy, and then we're visiting this guy. At the time we're rendering this guy, we need to take this piece and generate a piece of JavaScript. And in particular, we want to generate something like $set heap variable counter, the variable name, to 1, and then we also want to put in the closure name here as the third parameter, and the closure name needs to be main underscore closure, which, if you don't remember, that was the thing that was generated over here. Okay, so that's what we need as the third parameter. In order to know how to generate this, we need the name of the function here, which is main, right? We need, so this guy here, that's the function name. And the function name is in this node though, so if we're traversing the context of this subtree, it has access to this node, but not this node, okay? It doesn't have direct access to this node, so what should we do? Let me think about that. One possibility is we pass in the parent node or ancestor node, who is the function that this statement belongs to, as another additional parameter to the function, and then I have to introduce that new parameter to all of these potentially recursive functions. So that's one possibility. Another possibility is that actually can't think of another. Maybe like take this function node and stick it into that closure info object, but I don't like that because that can change over time, because one moment you're in this function, another moment you're in another function, and then we're gonna have to modify that closure info object, and I don't like that. So there's a third option, which is for the parser to allow two-way links so that the child node can also access the parent node. And then when we're dealing with the child, you walk upwards in the tree until you find the function node that you belong to. But I don't like that much either, because I don't know, so it adds to the amount of memory usage, and I feel like double E links are sometimes hairy, like when you have a thing that points in this direction and also a thing that points in the opposite direction. handling and updating and synchronizing those references could get hairy, and I kind of don't want to do that either. So, which brings us to, I think we probably need to pass down a scope, yet another variable, yet another parameter, which is maybe called the scope parameter or the function parameter, that represents the function node that your statement belongs to. Okay. Yeah. And it can be null. And initially it needs to be null. And if your statement is let me go look at that function. Okay, so yeah, this will pass in a fun node. Yeah, I'll do basically the same exercise we did with introducing this parameter. I'm going to do it with introducing the fun node parameter, which represents, but this one is not going to be, if you encounter a program node, then the program node is your fun node. So there's exceptions here. And if you are the code block, then your fun node should already have been provided. And most of these are just passed through, like return statement. But now at this point you have access to your fun node here. So I'm gonna write to do here, finish that up. So I'm gonna comment out these lines. And after adding this parameter, I'm gonna retest the code, just make sure I did all of that correctly before making that part work. Key thing about programming and staying focused is try to do one thing at a time, and that's not always easy, but you sort of just have to be disciplined and intentional about what you're doing at the moment and what you're not doing at the moment. Okay. So I'm just introducing this parameter. If I see a function expression or a function statement, this function definition, then that's the special case where I actually want to override the fun node to be myself. There's a function definition, so the fun node should be myself. Okay. Fun node. It's a fun node. All right. Okay. Okay. And then this one also gets a fun node because an if statement, it doesn't have specialized knowledge about functions. This one does. Yeah. Generate function. Let me think. Let me do, generate function is above that one. Maybe generate function, I should move it below the generate code for expression, I feel like. Okay, so I'm gonna add the fun node here and then see where I need to add it to in the other places. Generate call expression. Why that doesn't belong there? I don't think. This should probably be called closure info. I'm gonna make sure generate call expression is a function, right? 180. Where is it defined? Yeah. That should have been a closure info, and then it also needs a fun node now. Okay, that was extremely weird, but now it also needs a fun node which is available. Okay, this has a fun node. Okay, this is where I left off. Okay. Oop, no, what did I do? No. Okay, just adding fun node here as well. Okay, this is the special part where this is a function expression, and then the new fun node is just myself. Yep. And then as for generate function, actually, you know what? It doesn't need to be passed itself because it already has itself. It's that. So I'm not gonna pass in itself, and this knows that the node itself is a function. So whenever it needs to recursively call on another child function, I'll just pass itself in. And there's only one place where it needs to do that. Okay, let me go through all the calls for generate function and make sure it's passing in the right number of arguments, which is 2. Okay, I think I looked through all of the code at this point and introduced that parameter in the right places. Maybe I'm gonna test it. Oh, that just worked. That was somewhat surprising, but okay. Great. So at this point, I think I'm ready to do what I was about to do. Let's do this. So now I have the fun node, which has a name, and I can use that name to generate this closure variable name, and that's the closure variable name. It's $sign followed by the name of the function followed by underscore closure, and that is the thing I need to put in here in the case of set heap variable. Let's check if that happened correctly. No, it didn't. Value is oh, I need value to have been defined. Oh, and also I need this set var statement. I meant to put that here. Okay, let's see. Am I getting set heap variable in at least some places? No. Only the place where it was defined. So that was not right. Okay. Oh, I need to look up the thing I need to look up the provider for is not this statement, because that's the var assignment statement, but it's the fun node. That is what it is, I think. Yes. So yeah, so when you're modifying the counter variable, which needs to be in a closure, you are using the set heap variable. where you're modifying the label variable, you're using set heap variable, but for the other ones, you're using the normal set variable. Awesome, but also for the get variable, you do the same thing. So I'm gonna say closure provider equals closure info dot providers dot get, again, fun node, assuming we have access to the fun node here, which we do. And closure provider dot not that, but yeah, if there is a closure provider, which is going to be a set, and closure provider that has expression, which is a var reference, and a var reference has a var name, which is an identifier which has a value, then that's a string. Okay, so if all of that, then do our special case, but else do the normal case. And what should our special case be? It should be get heap variable with the closure var name in here. Closure var, and what is the closure var? That should be, again, we have the fun node name. The fun node.name is going to be an identifier node which has a value, and then closure. Okay, let's see that happen. And then do I have, yeah, we have get heap variable for label, and we have get, let me see. Okay, that hasn't trickled down to the inner function yet, but that's okay, one thing at a time. But for the function that is providing the closure, it is basically accessing the closure variables that it's providing using the get heap variable and set heap variable. That is true over here as well. Now we need to go in and modify the inner function as well, for the inner function case as well. So again, that would be for both get variable and set variable. Let's do the get one first this time, for no good reason necessarily. So I have closure dependencies. Okay. Oh, that should be dependency. Alright, so closure dependencies. So if I have closure dependencies, now I think I'm gonna prevent variable shadowing just by disallowing that in the language using a checker. So I'm not gonna worry about the case where the both, like this function is both provides, but it can't happen because this function either provides the variable or it's provided by a parent function. So it can't, the same variable cannot both be I'm providing it and I'm depending on another outer scope for that variable. So I'm going to say else if closure dependencies and closure I have to loop through all the dependencies though to find the right one, and if I don't find it, then I have to fall back to this one. So perhaps I move it in here. Oh, if closure dependencies, then I do all this stuff. I do early return, but if I don't manage to do early return, it'll fall back to this one. Okay, so now I'm gonna loop through for let dep in closure dependencies, which this is a dictionary, by the way. I'll show you. Okay, so we're looping through this map here where a key value pair looks like this. The left hand side is a node, and then the right hand side is a dictionary. These two are empty, but a dictionary that does have stuff in it looks like this. The key is the function name, and the value is a set of variable names. So loop through each key value pair and then say if is this variable inside this set or not. Okay, and if it is, then we'll do the heap thing. Okay, set is closure dependent dep this is fun name actually. So and then the set is closure dependencies, look up the fun name, and then that's set. So if the variable that we're dealing with, that one, let me just have an alias called var name so it's not so long here. Okay, so if var name, if the set has var name, then I'll do this early return statement. Otherwise, eventually it's gonna fall back to this return statement here. So if it is in that one, then we still need to figure out what the closure var is. And again, that should be fun name underscore closure, like that. And then again, we need this get heap variable. This would, let me make it shorter, call it var name. We can call it var name here as well. Yeah, I think that probably works. Let me see. That's only for the get variable though. So now in the inner, yeah, that works. In the inner function, when it's accessing counter, which is a variable from the outer scope, it's using get heap variable. But the set variable, we need to do it the same. We need it to use set heap variable. Oh, and it's using the right closure to get the variable from as well. This is from label, and this one is from counter. Yeah. So yeah, label was defined over here. Yep. Oh shoot, that's a problem. Okay, should I fix this bug? That is a bug. I still have to make a change to make it do. Let me. I have a bug, the object bug. Well, if I don't fix this, I'll eventually hit this because this is gonna be a JavaScript syntax error. So I'm gonna defer fixing this bug, and instead I'm gonna make the same change for set heap variable first. We're so close. We're so close. So this whole deal for set variable. Not this one, but this one. Okay. Closure dependencies equals closure info dot provider. Fun. Excuse me. Let me check my phone. Oh, actually, yeah. Check my phone. close to lunchtime, so I'm gonna check with my family to see if we're gonna go out to eat somewhere. Let me get my phone rebooted first before I can do that. Okay, so closure dependencies. I see. Okay. So maybe what I do here is I'm just gonna make a let just I think it'll be very gnarly if I try to do a crazy ternary. So I'm gonna make this let and then just set up the variable. Okay, so if that then we want that. Else it depends. Okay, I'm gonna get rid of this here. Yep, but else we need to loop through the dependencies as well. So if closure dependencies, we're gonna do this loop. Yeah. So for let fun name in closure dependencies. So the set of variables is that, look up that, and then if set has the var name, and again we calculate the closure variable like this. This only should take effect in that, and then we're gonna do this. Okay. Yeah, but this is in, well, what's the value? Value was here, and but this closure var is referring to this one, not this one. They're like scoped. Okay, and let me see. But we wanna skip this one if it's already been set. So only if this has not been set do we want to then set it. Okay, let's try that. Did that work? Set variable. I don't think that worked because that should have been set heap variable. So let me see. If closure dependency, I'm just gonna double check all of this code for possible mistakes. Sorry, one sec. I'm checking my phone. Okay. I haven't gotten a message from her, so I'm gonna try to finish this one up because we're so close. I guess one way I can debug this is to check for the case when we're setting counter. Yeah. So if we're trying to set counter, let me see. Oh, I'm gonna just print out the closure dependencies. Okay, within, I was setting counter in what function? The fun node that name that value. That tells you what function or value. Well, because it may not have a name. Okay, setting the counter in main, but over here is setting the counter in undefined. Oh, we didn't get any closure dependencies. Why? Ah, this should be dependencies. Okay, probably that fixed it, and it did. Wonderful. Okay. So, other than this bug, I think we got it. Okay. Do we have time to fix that bug? Okay. Let's try to fix that bug. Why do we have this object here? This is the case where we're setting label. So this should be the case where we're set heap variable. This statement, this just needs to be value. That was easy. Yep. Okay, great. And that fixes this as well. This might work. So I'm gonna go ahead and test this. The test HTML file already is referencing this code, which was just generated. So I'm gonna open it up and see if that works. No, it doesn't. Doesn't appears to have worked because I don't see anything on the screen. Okay. Closure is not defined. Line 14. But even before that, we had cannot read property line of undefined. That's the debugger erroring out. But also here we have closures. Okay, I see. In the runtime function, that should be closures, not closure. That's an easy fix. Bam! We have undefined closure somewhere. Okay. Undefined closure. So this is from a set heap variable as well. This is the same mistake because I copied this line from this line. Dang. Oh shoot. Because the function name is undefined. Wait. Line 63. Oh, wait, no, this one should just be fun name. it should be this fun name. Okay, let's see if that worked. Oh wow, it worked. Incredible. It worked, and you can actually step backwards in time through all of those click event handlers. That is a first. Wow, awesome. Okay, so I don't think we have. I'm sure there are bugs in the implementation. For example, the for loop counters are currently yet unhandled, but other than that, we've got closures to work. We've done all of these things, and closures, at least the first draft of the closure functionality in the programming language works, and we can step backwards and go back in time. I'm gonna also update my to-do list, maybe. Make closures work, and DOM events, that also works now. Okay, I got some other stuff that I could work on, but other than that, this looks good. This is very exciting. That means we can start writing some simple web-based applications that uses the DOM, such as a to-do list or a tic-tac-toe game, or just simple forms, dialogues, simple games, and stuff like that. And that kind of programming can make use of the back-in-time debugger, and that is very exciting. Future directions, there are many. I'm not gonna list them all now. But yeah, I'm gonna stop the stream here, and if you're still watching, then have a good day or good night.